Hi, good afternoon. Welcome back to JTech. This is Mark again. I'm here to teach you folks today, or hopefully show you folks today, on how to figure out what the total resistance is for a series parallel circuit and how to break down a parallel circuit in simpler form than using some of the equations that they have for us to use. The way I'm hoping to show you is fairly quick and dirty, and I think it'll benefit a lot of you in the long run. Okay, I'm going to sit here and show you, I'm going to show you right now that we have a 12.6 volt power source. I've labeled most of the resistors. I don't have this one on this side over here labeled yet. And I'm going to make this 1200 or 1.2K ohms. All right? All right, what our intentions are to do is to list up here our resistance total, our source voltage, and our amperage when we're all said and done, okay? So we know right now that our source voltage is 12.6 volts, all right? We can list that right now. All right, now what I want to do is show you how to take the largest of the resistances and use that to your advantage when it comes to figuring out how to figure out what a parallel circuit does. Okay, on the parallel circuit, we're going to get rid of this here. On the parallel circuit, what you want to do is take the first, or the largest resistance, and use that as your base number. So what we're going to do is going to put 1 over 1200 here, because 1200 is our largest number, right? And then every other number that we use is going to be divided into the 1200 so that it shows, so that we can get a factor for the top, and we'll have different numbers up here. These will all be over 1, and over 1. They will be added together cumulatively just like that. Okay, so the first number we're going to take is 60 into 1200. Well, 60 into 1200 is 20 times. All right, so that gives us a 20. All right, then we take the 40 ohms and we divide it into the 1200, and that gives us 30 times. Okay, and then we're going to take the 20 ohms and divide it into 1200, and that gives us 60 times. Okay, now what we're going to do are add all these top numbers together. So we got 90, 100, 110, 111 ohms is what we're going to, well, 111 ohms, but 111 figure over and above 112. So that would go like over 112 or over 1200, just like that. Okay. Then what we want to do is we want to invert these numbers, and we're basically going to take 1200 and divide it by 111. So I'm going to use a calculator to figure this out. So we got 1200 divided by 111 equals 10.8 ohms of resistance is what this whole area here is. It's 10.8 ohms of resistance, okay? So now we're going to take our series, because now what we can basically say is this parallel circuit is 10.8 ohms of resistance and can be considered, for the most part of the series circuit now. So what we want to do under our series circuit, we want to take, come over here, we're going to take our 40 plus our 80 plus our 100 and put it here, and that gives us 220 plus our 10.8. So we'll take our 10.8 and put it here. So we ended up with 230.8. So let's round that up to 231. You don't have to be exact, just got to be approximate. So we've got 231 ohms for the whole system here. Now what we want to do, and that 231 ohms will go up here, total resistance, right? Okay, so now with the 231 ohms, we're going to take 12.6, and we're going to divide it by 231 ohms, and that gives us basically 55 milliamps. Okay, so this is going to be 55 milliamps, 4.055 amps. So that's how you break down a parallel circuit and add it back into a series circuit and come up with a grand total of what you should see for an amperage draw through this whole system when it's lit off. 55 milliamps. I hope that has been of use to you. I know it was certainly of use to me when I learned it. I thought, wow, that needs to be shared, and here we are today sharing it with you. So I appreciate you guys checking in, and stay tuned for more meanderings and magic from my website. Thank you very much. Have a great day. Bye.